Hey guys, so this is Friday's assignment. You should have gotten the worksheet packet in class on Wednesday or Thursday, but if you weren't there or if you didn't get access to it or you lost it, this is the worksheet packet right here on this page here in OneNote, so you can access it that way. A couple things to kind of note in the way that this worksheet is written. This 3n minus 6, consider it in the parentheses. If they don't use parentheses, they're implying they're all in parentheses. Over here you can see that minus 5. It's not in the parentheses, so they're saying inside, outside. I think it only happens a couple of times, but like this, if you see it and it doesn't use the parentheses, we can assume that it's in the parentheses as a group. All right, so in all of these problems, the first 5, your job is to solve for x in this logarithm. And then you have to check your answer. You should always make sure that your answer isn't something weird. For the most part, I don't think you'll have any issues, but it's always worth checking. So the first thing is we have to get the logarithm with its parentheses completely alone. That v plus 2 is part of the logarithm, but the minus 5 isn't. So I'm going to move that to the other side. All right, so now I have log base 4 of v plus 2 equals 4. Now, I want to remove the logarithm. To remove the logarithm, we're going to jack the whole thing up, lift it up to an exponent position, and slide underneath it a base. Now, the base needs to match the base of the logarithm. So I'm going to do base 4 on both sides. On the side with the logarithm, my logarithm and base will cancel, leaving me with v plus 2 equals whatever this is, which is 4 to the 4th. I'm going to use my calculator to help with that. I believe it's 256, but let's just find out. 4 raised to the 4th. Sorry, 4 raised to the 4th is 256. So I know that v plus 2 equals 256, and so if I minus 2, that tells me that v would equal 254. The only thing you ever have to worry about is if your answer would make the inside of the parentheses turn to 0 or negative. If I add 254 to 2, I'm not going to get 0, I'm not going to get a negative, so I'm fine. If this was like 2 minus v, I would have a problem with a number like that. Okay, so that's the first part of the assignment. You're just going to go through and do that process, matching that log base as you go forward. Okay, so the next type is the same process except that they're ln. There's only 3 of them, but I wanted to make sure you guys were doing ln problems as well. So same approach, nothing's different to start out. I'm going to minus the 7. That might not be dark enough for you, but I get ln of b plus 5 equals 2. I'm going to change my color here. All right, now remember that the ln is base e. So when I jack this up to get rid of the logarithm, put it up in the exponent, the base I need to use is e. Now over here, the e and the ln of e will cancel, leaving me with b plus 5 equals e to the second. Now the answer key oftentimes is just minusing 5, and we would say that b would equal e to the second minus 5. But I'm totally content with using my calculator to turn that into a decimal. Because at some point it doesn't matter too much. It depends on whether we're doing a problem where we want to have an exact answer or if a rounded decimal is appropriate. Here 2.389. Either one of those two answers would be equivalent and sufficient. Keep in mind over here on number 7, that negative 3n, that's in the parentheses, but this negative 7 isn't, so that needs to be removed. Okay, so that'll get us through the first 8 or so questions. And now we're going to switch formats, or switch types of problems. Now we need to solve exponential problems. Those were logarithms, now we want to solve exponentials. And all of these have the same basic idea. We need to get our base and exponent alone. So here we can see it's 18 raised to the b minus 4. That's fine. I can't have anything else involved. So the first thing I'm going to do is get rid of this 6 that's multiplied. If it was plus 6, I'd minus 6. Whatever it takes to get rid of that other term. So now it's 18 to the b minus 4 equals And 62 over 6, it's some decimal. I don't know. 62 divided by 6 is 10.3 repeating. Now, I like the number 10.3 repeating generally, so I'm going to keep that in my calculator rather than rounding it. I'll just keep using the calculator for that. Now that I have an exponential alone, I need to remove the exponential. I do that by applying a log to both sides. I want to stick a log on both sides. But the base of the log needs to cancel the base of the exponential. Since my exponential is 18, I'm going to put a base 18. Over here it cancels. The reason I do it is to cancel the log with the base 18, to give myself b minus 4 equals log. Remember the base was 18 of 10.3 repeating. Now this is something that's got to go in the calculator. So watch how I do this. I'm going to grab my calculator. And there's the change of base formula, which is the log of the top number divided by the log of the base. So I can take the log of this number I've got in my calculator, close my parentheses, divided by the log of my base, which was 18. Close that parentheses, enter. My answer so far is 0.807, 0.808, I guess, 0.808 equals b minus 4. And then I add 4, b equals 4.808. If you're having a hard time evaluating logarithms like this, remember Desmos works pretty well. Other calculators will work. You just have to figure out how to make sure that you're getting it evaluated, typed in correctly. If I use a standard calculator from like a computer, there's my log, but it's not, it wants to already know what's going in the log. So it's a little bit different. If I were to try and do this, correctly, I would have to type the 10.3, then hit log. Okay. I'd probably write that number down, and then I would take, 4, or what's my base, 18, log, and that I'd write that down, and then I would perform the division. That's honestly how I would do it, to be careful about getting it. That's why these kind of calculators are not the most useful, but they do work. So anyway, that's how we solve those exponential problems. We get rid of them using logarithms. All right, we just have 1 or 2 more types. I think we're at 10, so we're narrowing it down real quick. More of this exponential stuff. Then we get to 16 through 20. Our job is to expand them. I'm going to take a look at question number 17. Try to remind ourselves of just a couple of things. First off, a cube root is the same as a 1/3 exponent. So this is the log base 2 of u, v, w, all to the 1/3 power. Now that 1/3 belongs to all of them. And so when I go to separate these, because they're multiplication, they're going to be separated as addition. So I have log base 2 of u plus log base 2 of v plus log base 2 of w, but the 1/3 goes in front of each one of their logarithms. So 1/3 and 1/3. This would be my expanded version. If it's division, like down here, I'd create a subtraction problem. But we're just trying to remember those rules of exponents go in front, things like that. On a question like 16, you're going to be happier if you'll distribute the exponent initially, making it x to the 10th, y to the 5th in the parentheses. That way when you separate it, you're only messing with one exponent per term instead of 2. Okay, hopefully that's enough. And what you don't understand, you need to chat me on Teams or email me or stop by the school and get the help that you need. We're coming up on a test pretty quick, so let's make sure you get the help that you need. All right, we'll see you.